This is a problem number 8 on packet 15. We have a particle, again, moving along the x-axis. Its position is being given by x of t is 1/3 t cubed minus 2t squared plus 3t plus 2. And we're looking for values greater than or equal to 0. Okay, so the first part asks us to find an expression of the velocity. The velocity is the derivative of the position function. So using our power rule, going to take the 3 on the exponent, multiply it by 1/3, that's 1, lower the power once, so I have 2t squared, same idea, 4t plus 3, the derivative of constant is 0, so the derivative of the 2 is 0. Okay, now we want a quick rough sketch of v of t. Well, it's t squared, so I know that that's a parabola, but perhaps we can get a little bit of a better sketch. And for instance, if I put in v of 0, I get 2. So I know it crosses the y-axis at 2. And then if I factor this, I could factor it into t minus 3 and t minus 1. And thinking about those, setting those equal to 0, I'm going to have roots of 1 and 3. So the parabola with roots 1 and 3, it's going to go something like that. Now remember, we just drew the velocity curve. And part C asks us, over what time intervals is the particle moving to the right? Particle moving to the right implies that the velocity is positive. Moving to the left, particle moving to the left, that means the velocity is negative. Should have written is positive here. So when is the velocity positive? The velocity is positive when the function is above the x-axis. So in these two intervals that are red, that's when it is positive. So between 0 and 1, and again when it is greater than 3. Okay, and then the particle is moving to the left, and the time in between, when the velocity is negative, the particle is moving to the left. So between 1 and 3. Part D brings us back to the fact that this particle is, it asks us when's the particle getting to its leftmost position on the x-axis. And I'll remind you that the particle is just moving along the x-axis, okay? And it tells us its position is given by this function. So when we need to think about a couple of things. First of all, at t equals 0, the original position of the function is 2. So this particle is sitting here at 2 when it starts. So that's at t equals 0. Then while the velocity is positive, so up here, when the velocity is positive, between 0 and 1, that means the particle is moving to the right. So at t equals 1, what's its position? Well, if we do that computation, we're going to have, let's see, looks like it'll be 3 1/3 if I'm doing that correctly in my head. So it gets to 3 1/3. But at the next point, okay, we're going to have this function is now, the velocity is negative in this region between 1 and 3. So what that means is the particle is now moving to the left. Okay, so it's sitting here, and now it's going to the left. And it goes to the left until t equals 3. And if you do that computation, I believe you get 2. So what has happened at t equals 3, the particles move back to the same spot where it started off at. Okay? And then the last part we need to consider, but ultimately it's not going to affect us to answer this question, because at t equals 3, the particle is going to be moving to the right as indicated by the velocity being positive. So at that point, particle switches around again. Where it goes exactly, I'm not sure, but it keeps moving to the right. Okay, so our answers lie in t equals 0 and t equals 3. Both of which time the position is at 2.